This section starts to put together a lot of the things we've learned from previous sections. Quadratic equations are quadratic functions that are set to a value. Standard form of a quadratic equation is ax squared plus bx plus c equals 0. And that's a common form that we've already learned. We know that when dealing with finding vertices that we look at a, b, and c, and we can use that to help us graph a parabola. The solutions of a quadratic equation are called the roots of the equation. One method for finding the roots of a quadratic equation is to find the zeros of the related quadratic function. The zeros of the function are the x-intercepts of its graph. So previously we talked about how roots, zeros, and x-intercepts all really mean the same thing. When you set any equation, not just quadratic, but any equation equal to 0, you're finding its roots, you're finding its zeros, and by setting an equation equal to 0, you're also finding the x-intercepts. So this section is about how to solve a quadratic equation by graphing. And if we're solving a quadratic equation by graphing, that means what we're going to be doing is looking for the x-intercepts of the graph. Where the x-intercepts are is going to be the solution to the equation. So looking at the first example, solve x squared minus 3x minus 4 equals 0 by graphing. First, verify that it is in standard form, that it is in that ax squared plus bx plus c equals 0 form. And this one is. So it is ready to be solved by graphing. So we will do our process for graphing, which we've already learned. And the first step is to find the vertex using x equals negative b over 2a. So a is going to equal 1, because that's the coefficient of x squared. B is going to equal negative 3, and C is going to equal negative 4. So negative b would equal negative and then negative 3 over 2 times the a value, which is 1. Negative 3 is positive 3, so that's 3 over 2. So the x value of the vertex is 3/2. And then we will replace the x in the original problem with 3/2. So that will give us 3/2 squared minus 3 times 3/2 minus 4. That's not going to likely equal 0. It might equal 0, but remember, when we set it equal to 0, we're looking for the x-intercepts, which are the solutions to the equation. We're still looking for the vertex, so this is more than likely going to be something other than 0. So when you do 3/2 squared, you get 9/4. And negative 3 times 3/2 will give you negative 9/2 minus 4. And when you add and subtract all that, you get negative 25/4. So that is the y value of the vertex. So I'll go ahead and graph that. So 3/2, that is over 1.5, and negative 25/4 is down about negative 6.25. So that's going to put us right here in the middle of a grid square. So that's the first step. Second step, remember, is to find the y-intercept. Well, the y-intercept is the c value, and that is the negative 4. So I'll just go ahead and put a point on negative 4 on the y-axis. So there's the second step. And then the third step is to apply our 1-3-5 rule. Remember, we have to take the 1-3-5 rule times the a value, which in this case the a value is 1, still gives us 1-3-5. So from our vertex, we will go out 1 each direction and go up 1, which is going to place its first set of points right here and about right here. And then when we go out 1 and go up 3, 1, 2, 3, that'll place a point there. And from these points, go out 1 and up 3, we'll place a point right here. And then from those points, we'll go out 1 and up 5. So 1, 2, 3, 4, 5. That puts that point there. And out 1 and then up 1, 2, 3, 4, 5 places a point right there. And we will draw our best parabolic curve. And it looks like it does go through the y-intercepts. That probably means we're correct. And then up to the other side. Throw a couple of arrows on there. And again, remember what we're looking for. To answer the solution, to figure out the values of x that make this a true sentence, we're looking for the x-intercepts. And the x-intercepts are right here at x equals 4, and it looks like right here at x equals -1. So our solution, we would say, would be that x equals -4 and x equals -1. You can actually verify, excuse me, not -1, it's -4, it's x equals +4. Let's correct that. There we go. X equals 4 and x equals -1. And you can verify that by plugging in x equals 4 into the original problem and see that it does equal 0. So if I replace the x's with 4, I would have 4 squared minus 3 times 4 minus 4. And that would be 16 minus 12 minus 4, and that equals 0. You can verify that if you wish. So pause if you want to verify it on your calculator or your fingers or whatever you choose to use. And you can also do -1 squared minus 3 times -1 minus 4, and that also equals 0 because -1 squared is 1. -3 times 1 is +3 minus 4, and you can see that equals 0. So this method does indeed work. So the next example is also to solve the equation by graphing. And notice this one is not set to standard form. We've got to get it set equal to 0. So to get it set equal to 0, I think the easiest way would probably be to subtract 14 from both sides. And that would give you -x squared equals -6x, and 23 minus 14 is 9. And then I would have to add the x squared to both sides. I'm not going to put it under the x because they're not like terms. So 0 would equal x squared minus 6x plus 9. So now it's in standard form because it's in that form of ax squared plus bx plus c, and it is set equal to 0. So that means a is 1, b is -6, and c is 9. We're ready to find the vertex, so we will use, again, -b over 2a to find the x value of the vertex. So that'll be -6 over 2 times 1. And remember, -6 is +6 over 2, which equals 3. So the x value of the vertex is at 3. And when you plug this in, plug it into the standard form, which is going to be this portion right here. So that will be 3 squared minus 6 times 3 plus 9. This is going to give me the y value. 3 squared is 9. -6 times 3 is -18 plus 9. And this time it does equal 0. So like I said, it's possible that that'll happen, even though it doesn't happen a lot. So we have a vertex located at 3, 0. And then we use the c value, because that's going to be the y-intercept. We already said c is 9. And since the a value is 1, when we use the 1, 3, 5 rule, that will give us 1, 3, and 5 again when we multiply times 1. So from our vertex, we'll go out 1 and up 1. There's the first set of points. Go out 1 and up 1, 2, 3 on both sides. Out 1, up 1, 2, 3. And then out 1, up 1, 2, 3, 4, 5. Out 1, up 1, 2, 3, 4, 5. Oh, looky there. We hit the y-intercept. That's a very good sign. And we draw our best parabola. Okay, so where's the solution? Where do we look for the solution? Remember, we look for the solution at the x-axis, where the x-intercept is, and it's right there. Only touches the x-axis at one place, so there's actually only one solution this time, and that solution is the x value of 3, because that is where the x-intercept is. So only one solution, x equals 3. It is the only solution that'll work for either this portion right here or even the original problem. You could plug 3 into both of the x's in the original problem, and it'll be a true sentence up there as well.